We're going to use prime factorization and fraction notation to simplify our fractions. So we're going to simplify fractions here. And I'm going to show you quite possibly in a way that you might not have been exposed to simplifying fractions in the past. We're going to take 20 over 26. 20 26 is how you would say that, or 20 divided by 26 would be written as a fraction form because it is a division problem. However, we just want to simplify our fractions. So we have 20 over 26. My first step is to prime factor the numerator and then prime factor the denominator. So we'll start there. Prime factoring the numerator, I'm going to take 20 and I'm going to put 2 into 20, which it does go in evenly 10 times. 10 is a composite number, so I put a box around it. 2 goes into 10 5 times. 5 is a prime number, so I found my prime factorization. 2 times 2 times 5. 2, 2, and 5 are the factors that make up 20 when I multiply all those factors together. 26, we're going to prime factor 26. 2 goes into 26 evenly, that's 13 times, and 13 is a prime number, so my prime factorization of 26 is 2 times 13. Now this step is very, very, very important, very, very, very important. You are going to find factors that create a value of 1. We're going to find a factor that creates a value of 1. So values of 1 would be any number over itself. So I need A over A. Now, if we want to think about this, we can say we've got 2 times 2 times 5 over 2 times 13. And then there is our factor of 1. So our factor of 1. Now, sometimes students learn that they just cancel out numbers. They just cross them off. But it's important for you to see that 2 over 2 is a value of 1. And that's what allows us to do the crossing out. And that's because 2 over 2 is 1, and anything times 1 is itself. In the numerator, we're left with 10, and in the denominator, we're left with 13. So 20 over 26 is equivalent to 10 over 13. 10 over 13 is the simplified fraction. Now you might be asking yourself, why can't I do this the way I learned a long time ago? Divide by 2, and that's 10 over 13. And some of you are going to potentially go around the prime factoring and reduce your fraction like this. And the reason being is because where we're going in algebra, where we end up going in college algebra and beyond, is we have to cancel out, we have to look for values of 1 with problems such as this. So it's not as easy to simplify an algebraic fraction when you were used to just dividing out numerical values. So we're going to practice simplifying fractions using our prime factorization. So let's do another one of these problems. Let's see what we have here. Let us simplify 24 over 30. So 24 divided by 30. So I'm going to prime factor 24 off to the side. I'm going to take 24, and I always start with the number 2 to see if 2 goes into that value. 2 goes indeed into 24 12 times. 12 is not a prime number, so I'm going to try 2 again, and 2 goes into 12 6 times. 6 is not a prime number. 2 goes into 6 3 times. 3 is a prime number. So 24 becomes 2 times 2 times 2 times 3. 30, we're going to start with 2. 2 indeed goes into 30 15 times. 2 does not go into 15, but 3 goes into 15 5 times. 5 is a prime number, so my prime factorization of 30 is 2 times 3 times 5. And then here we have 2 over 2, and then we also have 3 over 3. So what that leaves us in the numerator is 4, and in the denominator a 5. It's okay for you to cancel these out as long as you're understanding that what you're canceling out are factors of 1. Now I'm going to rewrite this for you so that you can see. 2 times 3 times 2 times 2 over 2 times 3 times 5. 2 times 3 is 6. So I have 6 times 4. In the denominator, I have 6 times 5. That's the same thing as 4/5 times 1. And 1 times 4/5 is 4/5. And this works very well with multiplying fractions. So once we know how to simplify fractions, it helps us when we're multiplying fractions. So that's what we're going to do next, is we're going to multiply some fractions together. We'll do some multiplying, dividing, and addition, subtraction.